Okay, now we're going to do a particular composition of transformations that is two reflections across intersecting lines. In other words, I'm going to draw a line. I have my little figure there. And I'm also going to draw another line that intersects my first line. First, I'm going to take my figure and I'm going to go across this line. Then I'm going to take my result and go across the next line. So, two reflections. So let's start with the first reflection. I'm going to mark my line as a mirror. Then I'm going to take my figure and reflect it. So I've done reflection number 1. Now I'm going to the other line that intersects my first line, and I'm marking that as a mirror, which is my line of reflection. It's just a different way of saying it. And I'm going to take my figure. This is the result figure, the one that's the image, not the original. We're taking the result of that first reflection, and now we're going to reflect it. And here we are. So this is what I get. And again, we have a special conjecture. And the first part of the conjecture is that there's a one-step process by which I could get from here to here. In other words, from the pre-image, which is A, B, C, D, let's see, E, F. Okay. Let's see. I don't know where my points are there now. It won't let me click on all of them. There we go. That's taking a long time. And now the final image. These are the double prime. Okay, so the idea would be one single transformation that gets me from A, B, C, D, E, F to A double prime, B double prime, and so on. The names are a little off here, so let's change them. A, B, C. Whenever we name a polygon, we generally name it in order, alphabetically. If we were to name it the other way, that would imply that I'd be zigzagging across the figure, which I don't want to do. All right, so the first part is what that one transformation would be. And basically what it's going to be is a rotation. So what I'm going to do is I'm going to take this figure and I'm going to rotate it around this point, the point of intersection of the two lines. Okay, but first I have to figure out how far that rotation would be. So what I'm going to do is I'm going to make a segment from B back to that point of intersection. And I think I'll make it dotted. And from B double prime back, and again make it dotted. Okay, so this is my angle of rotation, and I'm going to mark it as such. I'm going to mark my angle, and then I'm going to take my original figure and I'm going to rotate it according to that angle. I marked angle, rotate, and notice here's where it lands. So yes, rotating my original figure, my pre-image, gets me there. The next part of our conjecture is how that angle, the angle between the dotted lines, relates to the angle between the two lines that I reflected across. So let's look at that angle. I'm going to measure that angle between the two lines. This is this angle right here. HGI is 57 degrees. Now I'm going to measure BG, B double prime, and it is twice as big, 115.15. And again, I can experiment with this, and that angle will always be twice as big, no matter where my figure moves or how it moves. The angle of rotation is always going to be twice the angle between the intersecting lines.